Okay, in this video I'm going to show you a second type of parabolic curve construction, and we have a little more information on this one, and in fact this is the type of parabolic curve construction that you'll need to complete the parabolic floodlight reflector for your next assignment. Before we only had 2 points, and we actually ended up defining those points. So the only information we really had in the previous parabolic curve construction was the span of the parabola. This time we actually have the rise and the span of the parabola in this parabolic floodlight reflector. So I'm going to show you how to draw the parabola for this object. You can do the rest on your own. But I'm in my construction layer, and I'm just going to draw a rectangle, and I'm going to make sure that I have my polar tracking turned on, and then so I can make straight horizontal and vertical lines. But I'm going to draw a line from left to right at 6.5, and then up by 2.125, and then 6.5, and then back to the beginning. Okay. So that's kind of the boundary of the parabola, is what we just created. Now, we're going to divide the couple of lines like we did for the previous exercise, and the type of construction we're doing now is directly related to the y equals x squared algebra formula for a parabola. The general formula for a parabola in algebra is y equals x squared, and the divisions that we're about to do is based on that. So I'm actually going to, in your book, they only do like half of the parabola on their divisions. If you take a look at that, I'm going to completely divide this line and this line following the book as an example. So I'm going to use the divide command. Before we do that, let's check our DDP type. And on this one, it's a little different than the last one. I'm still going to pick this type of point for my own personal preference. Anything but really these two will work. But I set my point size at 0.05, and I set the size in absolute units, which the absolute units means that the size is not relative to the screen, the screen zoom, basically. Okay, so I'll select OK, and let's divide the bottom line into 8 segments. So I'm going to select that line. Ooh. I'll type in 8, and you can see my 8 line divisions there. And over here, I'm going to divide this into 16 equal segments. Okay. All right, so let's use the X line command, and let's create some construction lines. So let's create some vertical construction lines from these points. And now let's create some horizontal construction lines. Okay, so X line again, and let's pick horizontal. Okay, now I'm going to pick on the first one. Okay, now if you think about the general algebraic form of a parabola, y equals x squared, if x were to equal 1, which is this measurement, then y will also equal 1, because 1 squared is just 1. Okay. Now when x equals 2, y will equal 4. So I'm going to go 2, 3, 4. Okay. When x equals 3, y equals 9. So 5, 6, 7, 8, 9. And then finally, when x equals 4, y equals 16, which is the full length of this line. Okay, so there's our divisions for our parabola. So let's go to the visible layer and create a spline. So I'll go from the point here and then click on my intersection points. And endpoints and what have you, and then press enter 3 times, and then you have your parabola with the correct rise and span. So my original intent with this drawing was to have you complete the entire object, or the rest of the object by yourself, but I think there are a couple of dimensions or missing dimensions that may confuse you. I think they're actually implied dimensions but it might throw you off. So it'll just be better for me to show you how to draw the rest of it. So I'm going to continue in my visible layer. And I noticed when I drew that, it was actually behind another line. So what I want to do is to single click on the line, and you can see that it did select the visible line. Right click, draw order, bring to front. So it brings it on top of the construction line. Yours may not behave like that, so you don't need to worry about it if it doesn't, but mine did. So you can think of sometimes when you draw one object on top of another, it's like a layer, and you have to reorder the layers sometimes to get the line to behave correctly. But anyway, so that's why I had to do that. So I'm going to draw a circle with a radius of 3.5 and then extend the line I just drew to the edges of the circle, and then I want to offset by 0.3, and then I've created the top part. Now the missing dimensions, or implied dimensions, I believe is what they intended, but it is a little confusing, are the location dimensions for the bulb. And what I'm going to do, the vertical location dimensions, I'm actually going to draw the bulb down here. So my first move would be a radius of 0.8 on that arc, and I'll just draw a circle. And then I want to offset in each direction by 0.38, which is the width of the brass portion of the bulb. And then from here to here, I want to draw a horizontal line and trim everything that's below the horizontal line. Okay, so in this area on, we're not there yet. Let me offset by 0.62 and draw that portion. Okay, so the portion I was talking about that I think was an implied dimension is this area here and this area here, and I think the width of that will be 0.025. I think it's talking about the material thickness right there that's given in the note, and the height of that, I think this height will be 0.12, which is the height of one of the knuckles that's shown down in this area. So I'm going to close that in like that, and I probably could have just used the extend command to do that, but the reason I just drew it across is I want to offset by 0.12 and just offset that short segment up, and then trim everything above that line. Now at that point I can actually move, and I'm doing a left to right window, so I don't select the construction lines. I want to move up from this point to where the construction line crosses the parabola that we created earlier. Okay, and then continue your construction on down. So the next offset we want to do is 0.06, and the thickness, the width of that portion is 0.70, or the diameter of that portion in here is 0.70. So I want to offset by 0.35 in each direction. Okay, so I'll draw it from here. I'll draw it from here, and then I'll need to trim. Okay, now the next portion has a thickness of 0.12, so again, let me use the offset command to achieve that. I'll offset that down, and then extend, and extend. And you know what? I need to go ahead and extend this line to the outside and this line to the outside, and then close the gaps there. Okay, and then offset, let's see, again by 0.06, and again that diameter is 0.7. So trim, and then finally the bottom portion has a diameter of 0.12, so let me offset by 0.06 in each direction, and that length is 0.25. And so we'll just create a line from here to here. And then trim what we don't need. Okay, so I believe that is the completed parabolic reflector, except we need to get rid of this parabola between these two lines. So let's use the trim command to do that. TR enter, and I'll click on these two lines to make sure it trims in the right point, and then enter, and then click the parabola so that portion goes away. And I believe that is the completed object. So I hope this helps you out, and that concludes this video.